Okay guys, so here we're doing, as the video is titled, velocity versus time graph. So now this, instead of distance or position and time, we're talking velocity and time. Now before, with a position and a time graph, the slope was the velocity of the object because you took the rise, the distance divided by the time, and distance divided by time is velocity. Now if you take the change, instead of change of distance, we're talking about change of speed, change of velocity, and dividing it by time, the slope is the acceleration. So this is a positive acceleration. That means it's speeding up, gaining speed, second by second gaining speed. And then here, there's zero acceleration. Now, on the old graph, on a distance versus time graph, you'd be like, oh, it's not moving. See that it's staying in the same place over and over and over again. It's staying at this place. But this is not a place anymore. This is a speed. So it is moving right here. It's just not speeding up or slowing down. It's maintaining what's called a constant velocity. Or you can say zero acceleration. And then we got negative acceleration. It just means you're taking away speed every second. That's all. Um, so what is the acceleration here? What is that acceleration? All we have to do is do the rise. How much did it change its speed? Initial speed was 0. Final speed right here is 8. Okay, and how long did that take? 4 seconds. Let's take a quick look at this. Let's see if I can do this real quick here. Um, Remember the initial speed. Oh, okay, it's getting mad at me. Oh, because I'm on the wrong active layer. There we go. Um, the initial speed was, what was it? 0 meters per second, of course. And then it went up. And then so it started at 0. And then right here, it got to 8. So the final speed was 8 meters per second. And the time from here to here was 4 seconds, right? So that was a time of 4 seconds. And the definition of acceleration is simply the final speed minus the initial speed divided by the change in time. So pretty much it's 8 minus 0 divided by 4, which is going to give you 2 meters per second squared. And of course that's a positive 2 meters per second squared because it was gaining speed during that time. Now if we check off and go back here, what is the acceleration here? You don't need to calculate anything. It's 0. It's totally flat. It's staying 8 meters per second the whole time. So what question could I ask? I don't know. Is there acceleration here? No. That's a good question. What about, is it at rest right here? No, it's not at rest. It's moving. It's moving at 8 meters per second. What other good questions? How about how far did it move during this time? How far did it move? Well, it's moving at 8 meters per second for, let's see, from 4 to 7, that's 3 seconds. So 24 meters. If you want to see the proof on that, let's do that real quick. The proof on that is, remember, it's going 8 meters per second the whole time, just a nice flat line, correct? But remember, how long did that take? It was 4 seconds here and 7 seconds here, so that's 3 seconds total time, correct? From 4 to 7. So the velocity is 8 meters per second. Sorry, let me fix that. The velocity is 8 meters per second, constant. There's no acceleration. And the time is 3 seconds. And there's no acceleration, so we can use this equation when there's no acceleration. Divided by t. And so if you solve for x, delta x is equal to v times t. And so pretty much you just take 8 times 3 and you get 24 meters. Because it's going 8 meters, that's what this says, 8 meters every second, and it does it for 3 seconds, so then 24 meters. That's how far it went. And then let's do lastly real quick here to finish this video up. What's this acceleration? It's going to be negative. What's the final speed? Look at right here, when at the end of time. So at 7 seconds, the speed is what? Initially, 8 meters per second. Finally, at 10 seconds, that's 3 seconds later. At 10 seconds, it's 0. So we go from 8 to 0 in 3 seconds. Okay, so 7, 8, 9, 10. That's 3 seconds. 1, 2, 3. See? 10 minus 7. So that's 3 seconds. So let's lastly just do that one real quick here. Let me activate the layer. And so we start at 8 meters per second. And we end up at 0 meters per second down here because that's 0 and that's 8. And then the time it takes right here is 3 seconds. It was a 7 and a 10, and the time change is 3 seconds. So let's do the math here. Acceleration is equal to final velocity 0 minus initial velocity 8 divided by time. Oops, I do have the time. It's 3 seconds, right? And then that's negative 8 on top. Negative 8 divided by 3. And that's our answer. 8 thirds, but if you want to know the decimal, 8 divided by 3 is equal to 2.66. So negative 2.67 rounded, I guess, meters per second squared. So it has a higher acceleration rate. So that's another question someone can ask. I mean, there's all kinds of questions you can ask on this thing. You could ask, which has the greater acceleration, this one or this one? And the answer is this one. This one is more dramatic. It's 2.67, and this one is 2. Um, so, but the only difference is this is negative and this one's positive. But if you're just talking about what's called magnitude, okay, if you're just talking about how great and strong the acceleration rate was, the magnitude of it, then this one has the greater one, and this one has the smaller one. This one only has 2. It's the only difference is this one's slowing down, this one's speeding up. But other than that, it doesn't really matter. So, um, go ahead and try a couple practice problems on this graph, and we'll see how you do on those. Okay.